Welcome to our fourth and final subpart of the sequences and series unit. So here's our page 1 of stuff to know, vocabulary and so forth. So just like we had geometric sequences, we had arithmetic sequences, and arithmetic sequences had arithmetic series that are the sum of the terms. So geometric sequences also have geometric series. So the sum of the terms in a geometric sequence is known as a series. And an example of this is the series 2.5 plus 5 plus 10 plus 20 plus 40 corresponds to the sequence 2.5, 5, 10, 20, and 40. And so R is equal to 2 in that particular case. And we can see that every step in the sequence we're multiplying by 2. All right, so just like in arithmetic, they're both finite and infinite series. And infinite series for geometric series, because you're actually multiplying instead of just adding, although it's actually true for some adding too. If what we're doing is multiplying by a number that gets ever smaller, so let's say our R is a half, then our sequence would be 1, 1/2, 1/4, 1/8, and so on and so forth. R equals a half. That actually goes down to a number, and so it's called, or we say that it converges. And if we are multiplying, so if R is less than 1, we say it converges. But if R is greater than 1, so let's say our sequence is, let's say R equals 2, then our sequence would be 1, 2, 4, 8, and our series would be adding those up. Well, that just gets bigger and bigger to infinity. And so we say that diverges. So an infinite series will diverge. All right, and then the other important piece here are the formulas. And so when we have geometric series, they're also, just like with arithmetic, there are formulas, and you're going to want to definitely keep track of those because it's going to tell us how to plug and chug and solve. If we have a finite geometric sequence, then its series, or its sum to the nth term with ratio R, is going to be the first term A1 times 1 minus R to the n divided by 1 minus R. Another way of writing it is down here, and it is just, so S sub n is equal to A1 minus A1 times R to the n over 1 minus R. And it's actually just simplifying it. If we have an infinite geometric series and the magnitude of R is less than 1, then the sum of that series does converge to, so there's no n here because it's a total, A1, the first term, divided by 1 minus R. So a lot here, I know, to think about.